All right, I see we got quite a few people in here at this point, so I'm going to go ahead and get started. Just want to say hello, everybody, and welcome to the webinar on benchmarking soil health in Arkansas. My name is Stephen Piers. I'm the Associate Director of Sustainability at Cotton Incorporated. Cotton Incorporated has been a proud funder of the U.S. Regenerative Cotton Fund, and I just want to take a moment to let everybody know why that support matters to us. Our mission at Cotton Incorporated is to serve the U.S. producer and the industry built around U.S. cotton. That means we're deeply interested in the long-term viability and resilience of cotton farming, and soil health is central to that. Healthy soils are more productive, they're more resilient to weather variability, and more cost-efficient to manage over time. Farm-level economic analysis conducted across the Cotton Belt by SHI shown that adopting soil health management practices reduce production costs by $74 per acre and increase net farm income by $173 per acre on average. So that's not abstract environmental benefits, that's real money in the grower's pocket. So we support this work because it puts credible, locally relevant science directly in the hands of growers and their advisors. That's exactly what Cotton Incorporated exists to do. And for those who are less familiar with the Soil Health Institute, they're a 501c3 not-for-profit organization, and their mission is to safeguard and enhance the vitality and productivity of soils through scientific research and advancement. Today, SHI is pleased to host the second in a series of webinars highlighting their benchmarking work in Arkansas, Southern Mississippi River Alluvium. This work is part of the U.S. Regenerative Cotton Fund, and that is an initiative led by SHI to empower cotton growers and their trusted advisors with the tools, information, and networks they need to successfully adopt regenerative soil practices. During today's session, SHI soil health educator Emily Ball will share a brief history and overview of SHI's benchmarking approach, which helps farmers set locally relevant goals for improving soil health. She will highlight the key findings for Arkansas' Southern Mississippi Alluvium, representing 480,000 acres of cropland, along with some practical guidance on how to use those benchmarks to assess soil health. Following Emily's presentation, we have Dr. Bill Robertson. Many of y'all know he's a technical specialist with SHI. He'll offer a regional perspective and practical insights based on his longstanding work with Arkansas producers. A producer himself and formerly with University of Arkansas Extension, Dr. Robertson brings decades of experience in ag education and outreach. He'll share how soil health management systems such as reduced disturbance and cover crops are influencing results in the region. And we're going to conclude with a live Q&A session featuring both Emily and Dr. Robertson. So before we begin, just a couple housekeeping notes for today's webinar. It is being recorded. Both the recording and the regional reports will be shared after this webinar. If you have any questions, please submit them at any time with the Q&A box at the bottom of the Zoom window. Feel free to upvote any of those you see that you like best, and we'll try to answer as many as possible during the Q&A session. And with that, I'm going to pass things off to Emily to dig into today's content. Thank you so much.
Thank you, Stephen. And thank you to everyone who's joining. Like Stephen mentioned, my name is Emily Ball. I'm with the Soil Health Institute, and I'll be speaking about benchmarking soil health in Arkansas, specifically the Southern Mississippi River Alluvium region. So before I really get into the body of this work, I want to thank all of our supporters and collaborators, including Cotton Incorporated. They're the ones that are really making this work possible. And in addition to our supporters, I want to thank all our soil samplers. We started sampling on farms across the Cotton Belt in 2021, and lots of long, hot days in the field to prove it. But without them, we really wouldn't have the data to make this work possible. So with any conversation regarding soil health, I think it's really good to kind of start out with the definition, just to make sure we're all on the same page. So Here at the Soil Health Institute, we define soil health to be the continued capacity of soil to function as a vital living ecosystem that sustains plants, animals, and humans. So that's the same definition that USDA uses, but I think it's just really important to kind of level set to what do we mean when we say a healthy soil. So, with that, there are also four principles that kind of guide us towards healthy soils, and that's minimizing disturbance, maximizing living roots, maximizing soil cover, and maximizing biodiversity. So, just keep these in mind today when we're talking about soil health and think about what functions of a healthy soil are important to you and what are we discussing. So, SHI has kind of a unique benchmarking approach to soil health that I'll get into the function of, but just a little bit about our progress so far across the Cotton Belt. As of probably today, I might be a couple farms behind because we're out there actively sampling, but we've sampled across 402 farms in the regions highlighted on the map in the right corner. Um, and this is the information that's going to support our soil health benchmarks that I'm going to speak about today. And with that, we've sampled soils that represent over 12.5 million acres across the following states that are highlighted. And then as well as we've delivered over 1,000 soil health reports to the individual farms and land managers that we've sampled with. And then, like Stephen mentioned, this is the fourth of four regional reports we've delivered so far. The first three were in the regions in Texas, you can see highlighted, and they were delivered in or discussed in a webinar this past October. So, like we mentioned, we are talking about Arkansas today. So, we're focusing on the southern Mississippi River alluvium region. It's a bit of a mouthful, so I'll slow down so I don't trip up over it. But this region is highlighted here in the map. And this is one of the first regions we sampled. So, I'm really excited to deliver this information today in an area of a lot of cotton production across the US. So I think this is really important information that I'm excited to share. So I think it's important to get a good idea before we get into the data. What did we measure? So I think it's really important we understand what makes a healthy soil. We want to kind of figure out what metrics or measurements do we have to prove that. So at each location we sampled, we measured what we believe are the essential indicators of soil health. And we determined these in a study in 2019 where we looked at over 30 different soil health measurements on replicated long-term sites across North America, over 120 sites across North America. So we really wanted to narrow it down to measurements that were responsive to management, that reflect soil health, and that are applicable at scale. We want them to mean something no matter where you are in North America. So getting into the measurements, we selected organic carbon concentration. So we hear a lot of people talk about organic matter, but we felt that organic carbon concentration really was more responsive to management and was kind of getting at the function of carbon in soil, which is helping with soil structure, microbial activity, and nutrient availability. And we also reported organic carbon stock at the 0 to 12-inch depth, and that's going to estimate the total carbon storage of your soil within the first foot. The second metric is, or measurement, excuse me, is aggregate stability. And this is really going to be what happens when your soil comes into contact with water. So that's really important when we think of resistance to erosion and how you want your soil to maintain its structure when it comes into contact with water. And a higher aggregate stability, it's an index reported at a scale of 0 to 1. So a higher aggregate stability is going to mean better resistance to erosion and improved aeration and water movement throughout your soil. And I'll talk a little bit about ways to measure that. The third measurement is carbon mineralization potential, and that's going to really get at the biological activity within your soil. It's a measurement of the amount of carbon dioxide released by microbes after drying and re-wetting the soil. And that's going to reflect your soil's capacity to cycle nutrients. And the fourth and final measurement is available water holding capacity. And that's going to be the amount of water your soil can hold and then make available for plant growth. And that's really important when we think about areas of limited rainfall and drought resilience, because you really want to make sure that your soil is holding on to the rainfall or moisture it does receive and then making it available to plants. And so these are things that we believe really provide a strong, comprehensive view of your soil health. And so these things really depend on your soil type, management, how much rainfall the region receives, temperatures, climate, things like that. And so we really want to get at how can you account for these regional differences when trying to understand soil health in your area. So this is where our benchmarking framework comes in, and this is our approach of comparing different management systems within the same soil type. So we're looking at apples to apples. And the three management systems we look at are a baseline management, soil health practices, and reference systems. So we'll talk a little bit about what those are in practice, especially in this region. But I just wanted to kind of get you thinking about that we're looking at three different management systems within the same soil type. So we're comparing apples to apples, and we're not looking at references or goals for your soil that aren't relevant to your area. So this is just an example. Across the top, you see the three management systems I just discussed. And this is a real world example. I believe it was in the Pacific Northwest while our samplers were out sampling for another project. And you can see this is the same texture, same soil type, same climate, same area, region, all things being the same except management. And this is after an extremely heavy rainfall event. And you can see how a baseline conventional tilled system responds to that same rainfall event as the perennial less disturbed system on the right. So you can kind of start to see this gradient of fewer soil health practices or to no soil health practices, and then those principles really maximize for that region on the right. And so our baseline system is going to be kind of what's common in the area. It may include some soil health practices depending on adoption within that area, but not all of them. Soil health management systems are going to include the adoption of maybe one or more soil health practices compared to our baseline. And then our reference is going to be kind of representing the maximum soil health potential of this region, and is going to be continuous or going to include continuous living roots and little to no disturbance. So you can kind of see that this trend, which we do find throughout the rest of this data set as well, we're seeing lower soil health measurements for our baseline systems, and then gradually higher soil health measurements in our soil health management systems. And the maximum for this area is our reference. So we don't necessarily expect growers in kind of this soil health management system to reach reference values, although that was the case in this situation for aggregate stability. But we really just want to be able to provide the upper limit for this soil given climate constraints, climate and soil constraints to allow for relevant goal setting. So you can start to see this trend and just keep that in mind throughout the presentation. So specific to this region, in 2021 and 2022, SHI sampled 110 fields in this region, which is also Major Land Resource Area MLRA 131A and 131B. And this region is going to represent 480,000 acres of cropland. So the specifics for this area, our baseline system was in irrigated corn, cotton, and corn soybean rotations on annually prepared beds. Our soil health practices were irrigated corn, cotton, and corn soybean rotations on multi-year beds with annual cover crops for at least 3 years. And then our reference that we used as our upper limit were hardwood forests, unirrigated pecan orchards, and ungrazed grass. So I want to emphasize as well that this is within a cotton project, but these benchmarks are relevant to the crops that cotton is in rotation with as well. So in this case, corn, soybeans, and rice in some cases. So you can see, once again, our references are really going to max out the upper limit for soil health in this area and be able to provide local benchmarks for growers in this region. So getting into the data, in addition to management, we found that soil texture really influenced our soil health indicators. And so this table is going to show the value for two representative soil textures in the region. So across the top, we see a loamy sand soil at 5% clay and a silt loam soil at 20% clay. So we know there's a lot more than two soil types in this region. It's actually very variable. But we really wanted to choose the two most dominant in this region to kind of provide a range of values and show the differences that we found there. And then the indicators that we chose are on the left side of the table, those being organic carbon concentration, aggregate stability, carbon mineralization potential, organic carbon stock, and available water holding capacity. So we're not necessarily going to walk through every number in the table, but I just kind of want to point out some key themes. So the first one being, if we look at organic carbon concentration and under the loamy sand texture, we see a trend that at 0.62% for baseline, and then 0.67% for our soil health practices, and 1.17% organic carbon for our reference. So we see this trend that if we're incorporating more soil health practices, we have higher soil health values. So, right, this is something we, could hope for and assume from, the implementing more soil health practices, but it's great to see the data and the real life examples reflect that as well. So once again, this is going to give us an idea of what healthy soils look like for this particular region and soil type, and give growers an idea of a gradient or a range that they can compare their own values to. And looking at the other texture that we reported for this area, we saw the same pattern of values increasing with more representation of our soil health principles. So it's just worth noting as well that how different these values are between the two soil types. So if you look, our baseline are 0.62%, our soil health practices 0.67% for our loamy sand. And then for our heavier clay texture, or heavier in clay texture, we see 0.93 for our baseline and 1.0% for our soil health practices. So that's just going to be because of that difference in texture. It's soils that are heavier in clay tend to have more soil organic carbon. So keeping things like climate, region, and our management the same, texture is the only difference here, but you can see that it does play a big role. So once again, though, it does reflect that same trend of with more soil health practices and more soil health principles, we see higher soil health indicators. So let's look into some look at some of the details and trends we saw within this data set. So looking at the difference between baseline and our references, that's going to show us what the soil's potential is. And this is going to serve as, I guess you can think of, a logical maximum for what these soils can achieve under ideal conditions. Realizing that soils under in cropland are not going to necessarily reach our reference, but we can keep this in mind as a maximum for this area. So compared to our baseline, samples from reference had on average 90% greater organic carbon, 42% greater aggregate stability, 158% greater carbon mineralization potential, 57% greater organic carbon stocks, and an 8% increase in predicted available water holding capacity. So looking at our other measurements, an 8% increase in available water holding capacity might not seem like much, but I think it represents that the growers in this area, even at baseline, are doing a really good job of kind of maximizing that benefit of the soil. And it's also important to note that incorporating these soil health practices have other water saving benefits aside from water holding capacity, like reducing your evaporation and increasing infiltration. So that's just something to keep in mind, that we have a lot of room for improvement in some of these areas, but we're also seeing some really good progress from the growers there in terms of available water holding capacity. So the last slide was really what could be possible if we took all, if we exemplified all the soil health practices, which is not necessarily practical in a cropping system, but what could be possible and what are growers actually doing in the area where we see benefits. So looking at organic carbon concentration, growers using soil health practices had an 8% increase compared to baseline, which was not statistically significant. 16% increase in aggregate stability, which was significant. A 7% increase in carbon mineralization potential, not significant. And an 11% increase in organic carbon stocks, which was significant. And a 1% increase in available water holding capacity compared to baseline. So what this really tells me is that it's harder to build carbon in these soils, even using soil health practices, but we're seeing gains in aggregate stability and water holding capacity. And so this is showing that the growers using soil health practices are making a difference here. And the practices specifically in Arkansas that we reported were using cover crops and multi-year beds. And something to note too is this 1% increase in predicted available water holding capacity. That might not seem like much, but if you remember, the difference between our reference and baseline was only 8%. So the gains that we see here might be larger than you think, because there's only an 8% difference between baseline and reference. So this 1% increase in predicted available water holding capacity is important as well. And this also shows me the importance of looking at more than one metric. So, for example, if you were using, if you were reducing tillage and planting cover crops and you were measuring your organic matter or your soil organic carbon, and you weren't really seeing the needle move as much as you hoped, I think that can kind of give an incomplete picture of the progress you're making if you're not looking at more than one metric, including aggregate stability and your available water holding capacity. So I think it really just shows the importance of looking at the whole picture rather than hinging everything on one measurement. And so this information I think is really important, but we really want to think about how this could be important or interpreted for growers that are wanting to learn more about their soils on their own farm. So for farmers we sampled with, this is an example of the report that they would receive. I'm not going to go through the whole thing, but just looking at our box plots, and these are going to show, for example, available water holding capacity. These are going to show the values expected for each management system, our reference, our soil health practices, and our baseline. And the red vertical line is going to show the value for each individual sample. But however, if you weren't one of the farmers we sampled with and were out of your region, how can you make this information valuable to you? So we're working on ways of delivering that. One of them being our soil health portal, which you'll probably hear more about in the coming months. But until then, we really wanted to think about ways you can look at this data with information that you may have or can get pretty easily to make it relevant to you in terms of how you're doing in your area. So one of the ways you can walk through this information, if you have not checked out Web Soil Survey, that's something I'd encourage you do. It's a free resource by the USDA NRCS, and it's a really, really powerful, cool tool to kind of look at what soils are mapped in your area. So the caveat there is that you may go out and say, well, that's not exactly right. I kind of have more of a heavier texture here, more sand here than they're saying. But it can put you in the ballpark of what soils are common for your area or for your field. So with that caveat, if you have no idea what soils are in your field, I think this is a kind of cool place to start. And soil tests especially will be more precise. They can break down your percent sand, silt, and clay. But once again, this just puts you in the ballpark. So for example, a field in Arkansas, we can check it out that it's mapped to predominantly Dundee silt loam, which is the predominant texture in this field that's mapped. So that gives us the idea that if we're trying to compare our soil health values to those on this chart, that we're probably leaning towards more of that silt loam texture, 20% clay. Once again, our soil, if we were to go out in the field, send our samples in, may have 21% clay, 19% clay, but this once again just puts us in the right ballpark and tells us that we have too much clay in our soil to be looking at these loamy sand values. So if we kind of have this idea that we're looking at this half of the chart, what other information do we have? So in this situation, maybe we have a previous soil test. Maybe we don't have soil organic carbon, but we did report organic matter for a field. And for example, just kind of walking through this anonymized soil test. So say our average organic matter for this field was 2.3%. So although we report soil organic carbon as one of our indicators, you can convert an estimate of soil organic carbon from organic matter. So this approach isn't perfect, but it gives you an idea of what your soil organic carbon is for this field. So if you have 2.3% organic matter and you divide that by 1.72, you can estimate that your soil organic carbon for this field is 1.34%. And once again, you may have already had your texture determined here. And that's where you could get a better idea of where your texture falls between the two that we reported. So looking at this half of the chart for silt loam texture, an estimate of 1.34% organic carbon, we can see that we fall kind of in between the soil health practices and our reference. So gives you a pretty good idea that you're doing well, you're making some strides, and even under the most ideal conditions, you can probably only reach that 1.76. So It's up to the grower, but I think I'd be pretty happy with that. So another way that we can kind of look at where we fall or how our soils are doing is by measuring our aggregate stability. And we have a really cool way of doing this. It's with our smartphone, and it's a free app. This was developed by SHI and the University of Sydney. And what it does is it uses your smartphone's camera to take a picture of your soil before it comes into contact with water and then after, 10 minutes after. So it uses the camera to get an idea of how it disperses. And once again, this app is free to download. So I encourage you to scan the QR code or check out our website to see the fact sheet and where you can download the app. So in this example, we've set up our Slates app. You can take a look at things you have around the house to use as a smartphone stand. In this case, it's a jelly jar, seen a soup can, things like that. But the idea is it's things you have at your home. And you can see that, these three aggregates, when you put into a Petri dish, in this case, you can use a cup, things like that. And it takes the initial image and then you add water and you can see this kind of progression of dispersion of your soil particles. And the app does a really good job of walking you through this. So you kind of take your first image and then you add water and then you go to take your final image at the end and it generates your aggregate stability index. So in this case, for our soils, in this example, our aggregate stability is 0.46. Looking at our benchmarks recorded in our regional report, we know we're looking at the silt loam texture, and our aggregate stability values are going to range from 0 to 1. And we know that 0.46 puts us smack in the middle of baseline and soil health practices. So this is something, we really recommend directly measuring your soil health for accuracy, but these values provide a kind of approximate comparison for a few of our indicators to see where you fall. And if you're working on implementing soil health practices, it looks like, you're well on your way to seeing some improvements while also understanding what the maximum is for your area. So in summary, just some takeaways from today's presentation. This report helps us understand how healthy soils can be in the southern Mississippi River alluvium region of Arkansas. And understanding that each region is unique, the practices that we found in this area were planting on multi-year beds and adding annual cover crops. Those are where we really saw improvements in soil health for our farmers in this region. And since cover crops are used on only 10%, or excuse me, less than 10% of cropland in this region, more farmers in the area could benefit from improving the health of their soils. And our regional benchmarks that we've provided here can really give you context for your soil health and help you define realistic, achievable goals for you and your soils. All right, and thank you all. That's kind of the end of my formal presentation. With that, I'm going to stop sharing and invite Dr. Bill Robertson to come and share some insights and join us for the Q&A. Hi, Bill.
Hi, Emily. Hi, everybody.
So, yeah, I guess I'm just kind of thinking about what we've seen here today. And, I've visited Arkansas a few times for me, but you've spent most of your career there. And I guess I'm just thinking, what are some of the challenges that you see when growers, it's easy for us to say you should be doing these things, right? But kind of in
Yeah,
practice, what are the challenges you see when growers, are wanting to improve their soil health, incorporate cover crops? What are the challenges that you see or the barriers?
yeah, that's a really good place to start. But let me back up a little bit because
Yeah,
I
for
really
sure.
want to thank Stephen and Cotton
Oh, yes.
Incorporated for their interest and support of a lot of the soil health effort that's been done here and in other places. I know they were very instrumental in a lot of the work that I did, and I appreciate working with you, Emily, and Misty on this webinar. But I know, you know, doing things different is always a challenge. And and when we look at something new that, there's, you know, I guess if you look at adoption of new technology, and I worked with that in extension because part of an extension specialist is to look at new technology and evaluate what's extendable and what isn't. Because some new technology isn't really extendable, but this is something that I really believe in, and I really feel like when you look at the folks that adopt new technology, our innovators have really latched onto this because we have innovators across the state that have been doing cover crops and improving soil health for a long time. And now then we're kind of getting to the point where in the early adopters and into the early majority. And if you look at kind of how those people work, they're more data driven. Because, our innovators, they see something and say, just a light goes off, say, oh, I can make that work. And then they figure out how to make it work. As we get into more of the mass, then we need more data. And this is something, Emily, that I feel like soil health is really on the spot on, giving more information, more data on where we can go, where we can be. And, when you look at things, you talk about 8% increase in water holding capacity and then a 1% increase in predicted. Sometimes it doesn't sound much, but when you look at what's going into soil, because soil's alive, right?
Mhm.
And so we're all alive. What do we need? We need food and we need water. And so the things we're looking at with the organic carbon content and the carbon mineralization, that's the food.
Mhm.
And then the aggregate stability and the water holding capacity, that's the water. The better soil structure you have, the deeper the water goes. And I really feel like working with farmers, I've tripled or quadrupled our effective rooting zone. So if you have an 8% just in the 6 inches, then if you take that down to the 12 inch and then all the way down to 18 inches, look how much more water you have available to the plant. And as a farmer, the easy way to tell, when I worked with farmers, we split fields in half. Into the heat of the day, when you go out there and look, the side of the field where they were doing the things they've always been doing was the plants are wilting down, saying, "Man, I'm hot and I'm thirsty. I need to drink water." But on the other side, where we had to, and we just did cover crops and try to reduce tillage, that the plants were nice, big, healthy, and perky, and so there's a lot of observation things you can make out there to go along with some of the things you've done, but just doing things different is the big thing because that's not the way granddaddy did it. That's not the way daddy did it and all that. And so I really feel like, when I worked with farmers to try to get them to start thinking about cover crops and using cover crops, just keep things simple. And the thing that I started with was just a straight cereal rye. I think cereal rye is a great starting place because it's pretty easy to get a stand and it's pretty easy to terminate and just try it on a few acres. And it's a lot of times not on the main highway because everybody think you're crazy. But anyway, but try it on a few acres and grow into it because I've heard a lot of people say that cereal rye is the cover crop of training wheels. But just doing those things different because look at our input prices and look at our commodity prices and it's hard. Farming's getting where it's not. Sometimes it's not a lot of fun. You need to have fun doing what you're doing, and so in trying, keeping the banker off your back and all those other things. We've got to do some things different because what we're doing now is not working so good. But just doing those things different, I think, Emily, is the biggest challenge.
Yeah, absolutely. Absolutely. Yeah, I really think about I was kind of surprised to see the 10% adoption of cover crops in this region. Maybe it's kind of the bias of visiting with you and hanging out with you and your friends because I was really shocked with the kind of the 10%. Do you feel like that's representative growers in this region, or do you think it's on the up and up, right? Do you think growers are interested in adoption and it's coming, or
I feel like there's a lot of interest, and
yeah.
you kind of go through pockets. You drive through the Delta, and you'll see a pocket where there's quite a few people that are looking at cover crops, and then you'll go through an area where you don't see any cover crops,
Hmm.
and uh, and so the interest is there. But realistically, about the last three falls, Mother Nature has not been very kind to us
Yeah.
because it's hard to get those cover crops, those winter annuals established in a fall when it's so dadgum dry. Look at, drive through the country right now, what's going on. There are dirt pans moving dirt all over the place. This time of the year in Arkansas, the ditches should be full of water. This fields should be too wet to do anything. We should be trying to pick and choose what fields maybe we can plant some early beans and early corn in right now at the end of March. And I have a feeling, we got planters running, but they're not going to run very long because they're going to run out of moisture.
Yeah.
And here on our farm, we're 25 inches short for the year, and so it's dry.
Yeah.
And so Mother Nature hasn't been very kind to us to get cover crops going,
Yeah.
and that's been a challenge. But if farming was easy, everybody would be doing it, wouldn't they?
Yeah, absolutely. Um, just kind of looking through some of the questions. We have a couple in the Q&A. I think this one might be a good one for you, Bill. So, could you speak to a little bit about growers using multi-year beds and kind of what does that look like in practice?
Yeah, that's, ever since, even when I was in graduate school at Texas A&M, we had heavy clay soils.
Hmm.
And in Louisiana, when the stale seedbed approach come out, and that was great because we could harvest our cotton, shred our stalks, and if we need to hit the rows up, we could hit the rows up, and then stay off the field. When
Hmm.
we stayed off the field, it was amazing how much those hard clays would mellow out through the winter and go in there in the spring and just with a burn down. And back then we were still running a do all in front of the planter, so we run a do all in plant. And so we had very little field operations, and so that really reduced a lot of our compaction. Then I know Steve Stevens in Arkansas tried doing the stale seedbed approach. He made a few tweaks, and then, a stale seedbed type approach is very common. You know, I was in Newport this week, $5 diesel on road diesel. We can't afford to burn much diesel, so we have to do as many things as we can and reduce the tillage operations. But going into our old established beds, I think is really we have to do that, and most people are doing that now. And so that there's I think it changes a few things in the fertility aspect and all that, but very very workable. But those are things that you know we don't have a choice. We've got to be doing that. As
Yeah.
far as if there are any particular issues with that, I don't know exactly where the question was coming from.
Hmm.
But using a stale seed bed or our old beds are pretty common. I know in the Midwest and some other places they skip over half a row and plant.
Hmm.
We don't do that here. But
Hmm.
going back in that same bed, the big thing is, if you're going cotton behind cotton, is to shred your stalks high enough so stalks that are really short. You go back in the next year to plant, and they just tear the rubber banding
Hmm.
wheels up on your planter. So they shred their stalks a little higher, and then they work around that. But there's certainly a lot of workable things to do to make that system work well.
Yeah, absolutely. Absolutely. Lots of trial and error, I'm sure.
Yeah, yeah, we back into so many things. I know I do, but you go along and think we know what the picture in the book looks like, and we know what we need to be done, but sometimes we just do the best we can do, and sometimes we end up doing something that was completely unplanned, and you look at it and say, "Hey, that worked pretty good," and you think, "Okay, well, I'm going to do that again." So sometimes we see things, farmers. I think I was at a presentation one time, and the the one of the speakers said, regardless of the education level of a producer, I think nearly all producers have a PhD in observation. Because when you do things that aren't quite right and you see that they work, well, they know that work. They may not know why it worked, but they know it worked.
Hmm.
And so they just keep doing those things that worked. And so we just kind of keep doing those things.
Hmm. Absolutely. Another question from the chat. Let me see. So you might have hit this a little bit, but so what's the first improvement that you think growers will really start to see when implementing these practices?
Well, the there are some things that I think, if we go to a full regenerative system, I think that's a 3 to 5 year. But when I
Hmm.
first started working with farmers and we split a field in half and I put cover crops, I just put cereal rye, you know,
Hmm.
I I had to learn a lot of things myself because you can't, as a salesman and trying to educate producers and sell things to other people, you can't sell something to somebody that you don't believe in, that you don't know.
Yeah.
And so I went into some of the first fields. There was a hard pan. Even back then I was like a 350-pound Bill Robertson. I could not hardly get a shovel in the ground much past about 2 or 3 inches deep. So I thought, okay, I'm going to plant cereal right here, but do I need to bust the hard pan up to get through that? And our innovators say no, you don't need to because the roots of the cover crop would do that. And I didn't quite believe that, but they ended up they all knew what they were talking about. Uh, but increased water infiltration is one of the first things. I thought when we did that, I see people go out there with a shovel and dig up, and there were earthworms everywhere. Okay, I
Mm.
figured, I said it probably may take 2 or 3 years before I can go out there behind a cover crop and just find earthworms everywhere. Well, I'll tell you what, I was so surprised after that first fall where we had a cover crop. When it come to planting time, I'd go out there with a shovel and we had cereal rye. I had just great, extensive, just massive amounts of roots. And there were earthworms everywhere. And you go to the tilled side, you'd have to dig down maybe 10, 12 scoops before you could find an earthworm. They're there, but when you feed them, well, then there are a lot of them. So we just had to feed the soil, and so some of those things are some of the first things you see. Into that second year and third year, a lot of times when we'd water cotton down the road, the water would soak up about halfway to the top of the bed. The top of the bed would never get wet. By when we got into the second year and especially the third year, water would soak all the way up to the top of the bed as we greatly improved water infiltration. And working with Mike Daniels on the Discovery Farm on some of those, we put meters on wells so we knew how much water the well was pumping. We had flumes at the end so we knew how much water was coming off. When we got into that second, third year, our water infiltration, we were getting twice the amount of water into the soil. And so some of those things really come along. And, you know, it's, those are the good things. And some of the things we had to adjust on. I worked with farmers and we would split the field in half and they'd keep their nitrogen fertility strategy the same. And so on the side where they tilled, we had a root system that only got about 6 or 7 inches deep. On the side where we did cover crop and greatly reduced tillage, I had soil moisture sensors. I was getting water down to 6, 12, and 18 inches. On their side, sometimes a single rainfall event or a single irrigation would not get to the 6 inch side. So then I tripled or quadrupled the effective rooting zone, but we were still putting all that nitrogen out. At the end of the year, I had a cotton plant that was not tired. It was not ready to shut down at the end of the year. And so it was hard to defoliate. And so one of the first things I had to do, I had to start cutting back on my nitrogen rate was it was too much fuel for the fire. Because at the end of the season, I think I think of a cotton plant like my grandbabies. When the grandbabies come to see us, we are outside, we were busy, we were doing things because at night when it's time to go to bed, I want them to be tired and ready to go to bed. And so at the end of the day on that cotton plant wasn't tired and ready to go to bed like it needs to be to make our defoliants work and all that and to get it harvested on a timely manner. And so I had to start cutting back my nitrogen fertility. So there's some things that work good and that worked good, but if you kept doing what you were doing and didn't adjust, then it caused some issues. And so those are things I had to learn.
Yeah,
So
absolutely.
sometimes we don't think about stuff like that.
Yeah, keeps you on your toes, I'm sure.
Yeah.
Another question. Oh, you will like this one. Grazing cover crops. Have you seen anybody in your area or this region kind of start doing that? How's that experience been?
Yeah, I know Farmer Hankins here in Oil Trough, he's got some cover crops, and my brother-in-law takes some cows over there. Farmers talked to me about taking some sheep, and I did a small study using sheep to graze cover crops, and it worked good. But the thing for me, my wife and I were a small operation, so the grazing of the cover crop happens the same time that we're lambing. And so there's not enough Bill Robertsons and carries to go around to take care of everything, so we can't split everything up. But where they graze the cover crops, you talked about the four things a while ago to improve soil health. And I think of them like a four-cylinder engine. That's to keep the ground covered, have diversity in your cash crop and your cover crop, have living roots in the soil as many months out of the year as you can, and then avoid the deep tillage because the first three things build soil structure, and when you do deep tillage, it tears it up. So that's a four-cylinder engine. And I feel like adding livestock to the situation is like putting a turbocharger on that four-cylinder engine. That just really kicks things in gear because that adds to the amount of diversity that's in the biological system when you add livestock to that. So livestock are great. And small ruminants, large ruminants. But the thing for me, it was difficult for me because I just didn't have the time to do it. Now I worked with farmers in the bottoms and they've kind of got out of livestock. And so they don't want to have to haul water. They don't have to build fence and all that. So I think there's an opportunity to maybe contract some things and do things because having livestock in the system is good, or I mean, is really great. But there's some labor challenges because our equipment and our labor right now in row crop is stretched as thin as we can get it. It's about to pop loose. So having those other things, and we got to have somebody that can do that and help generate a revenue stream for both people to make that work. And so a lot of times we get around introducing the livestock into the system by using poultry litter and some of those things. So we get some the livestock influence through that. But that's definitely a thing. If we were smaller, we could do a lot of things. But as big as we are right now, we just have to do the best we can do. And sometimes getting livestock out there is just kind of a challenge.
Yeah, absolutely. With fencing and water too,
Yeah.
considerations, it's a
Hauling
lot of,
water. Yeah. Yeah.
yeah, a lot of labor. But yeah, great when you can make it work.
Yeah.
Um, one of the questions we had too, so I heard you kind of mention it briefly, but cover crops to address compaction. What are some ones that you found do a really good job, and any kind of suggestions on how to address that without tillage? Or does tillage have to happen in some cases?
Well, I thought tillage did have to happen because that first year I put just straight cereal rye cover crop out there. And then I got one of those, our barred one from Joe Whittington. He had a little 4.0 rig. It's a DMI uh, high residue subsoiler. And so I carried that around to some of the different places where I did that. And I did strips in the cover crop. And I could go in there after the cereal rye was up and go in and do that. If you set that right, it busts that hard pan, but it doesn't bring clods up to the soil surface and all that. So I had to have a pretty good size. So I had to borrow tractors to pull that because it took a pretty good tractor, bigger than my little 75 horsepower tractor could do, pulling things. And so I followed that through the year. And in the spring of the year, I could see a difference where I pulled that subsoiler. But when we got into the heat of the battle on the cotton crop, when we get into flowering into fruit field, I could not, with penetrometers and other things, I could not tell where I'd run that subsoiler and where I hadn't. The Having a cover crop with a massive root system is the best thing to do. Because a lot of times, when we do, if we have compaction out there, we think, okay, we need to run a chisel plow. Okay, we run a chisel plow. First time we water, it takes forever for the water to get out. The next time it runs a little faster, then it runs a little faster. That's where your aggregate stability thing comes in. Because when you have good aggregate stability, the silt in the soil particles don't melt like a sugar cube, and they stay together. So, but if you do not have aggregate stability, it melts, and then the channels you made through the field with your deep ripper get silted in. Because most big farmers have track holes, and they have track holes to improve drainage off the field because the ditches that it gets silt in them. And so I call that your horizontal drainage. So they keep their horizontal drainage. So when you run a ripper, I think of that as vertical drainage. And so the vertical drainage, when you don't have a good aggregate stability, it silts in just like your ditches of the water running off. And so when we got into the heat of the battle, when the cotton really needed the water and the nutrients that come along with it, the ditches we made with a ripper had already silted in so that they weren't doing anything. And so that a ripper, we burn a lot of diesel, and the benefits are very short-lived. When we do vegetation to bust that hard pan, it lasts. And so cereal rye, I think, was my best one. But anything that deep rooted, the tillage radish didn't do much for me. But the nutrient sequestration and some of those things for a tillage radish that's where that falls in. But you need something. I like the grasses with a heavy root. The cereal rye triticale work way better than wheat. Wheat just does not have the density of the root that the cereal rye or the triticale has. And so, but my favorite one to lean on the most, especially being a cotton guy or if I was a soybean guy, would be the cereal rye. But I like to have cereal rye. So I need grasses. I want a lagoon. I want a brassica. And I want to have a mix. I want to have a mix of different things out there. Because when I go to a salad bar, I don't get just one thing. I get a mix of things. And the soil microbes are the same thing. So we need to take good care of feeding the biology of our soil.
Yeah, I absolutely agree. So, well, I think that's just about the questions we have time for today. Thank you so much for sharing. Of course, it's always a pleasure. You have a wealth of knowledge that we like to borrow sometimes. And thank you, Stephen, once again for your support and the support from Cotton Incorporated. We couldn't do this work without you. Um, we are looking forward to continuing these conversations. We're going to have our Georgia webinar next month. And please watch for a follow-up email with a survey, the link to this webinar, and some other resources. So thank you all again, and hope you can join us next time.
Bye, everybody.
See you.